More than 4 decades ago, humanity launched 2 spacecraft on a mission that was never expected to last this long. They were built during an era when computers had less processing power than a modern calculator. Their original purpose was straightforward: explore the giant planets of the outer solar system, send back photographs and scientific measurements, and then slowly fade into silence as their power supplies weakened. But that is not what happened. Instead, the Voyager spacecraft became the longest-running exploration mission in human history. Long after completing their planetary encounters, they continued traveling outward, crossing the vast distances between the planets and eventually reaching a region no human-made object had ever explored before. Today, Voyager 2 is more than 12 billion miles from Earth. At that distance, communication becomes an extraordinary challenge. A radio signal traveling at the speed of light requires more than 18 hours to reach the spacecraft. The response takes another 18 hours to return. Every exchange is a conversation stretched across nearly 2 days. And yet, despite the immense distance, Voyager 2 continues speaking to us. Each transmission arrives as a faint whisper from the darkness beyond the planets. Embedded within those signals is information about a region of space that remains one of the least understood environments in modern astronomy. Recently, scientists analyzing Voyager 2's data uncovered observations that are changing how researchers think about the outer boundary of our solar system. For decades, textbooks described the solar system as being surrounded by a vast protective bubble known as the heliosphere. This bubble is created by the solar wind, a continuous stream of charged particles flowing outward from the Sun. As the solar wind expands through space, it forms an enormous region dominated by the Sun's magnetic influence. The planets orbit safely within this protective cocoon. But eventually, the solar wind encounters the material between the stars. At that point, the influence of the Sun begins to weaken. The boundary where this transition occurs is called the heliopause. Scientists once imagined the heliopause as a relatively simple frontier. A dividing line separating the solar system from interstellar space. Cross the boundary, and you enter a new environment. Simple. At least, that was the expectation. Voyager 2 has revealed something very different. The spacecraft's measurements suggest that the heliopause is not a smooth border at all. Instead, it appears to be a complicated and constantly changing region filled with magnetic disturbances, fluctuating particle densities, and enormous structures stretching across millions of miles. Rather than resembling a wall, the boundary behaves more like a coastline shaped by powerful cosmic currents. As Voyager 2 moved deeper into this frontier, its instruments detected unexpected variations in plasma. Plasma is often called the fourth state of matter. It consists of electrically charged particles and makes up most of the visible universe. Scientists expected plasma conditions beyond the heliosphere to be relatively stable. Instead, Voyager observed sudden changes occurring across surprisingly short distances. Some regions contained much denser concentrations of plasma than anticipated. Others appeared unexpectedly sparse. These transitions occurred rapidly, suggesting the existence of invisible structures that earlier models had failed to predict. Researchers soon realized they might be looking at something far more complicated than a simple boundary. The outer edge of the solar system appeared to contain layers. Multiple layers. Each with distinct characteristics. Each interacting differently with incoming particles and magnetic fields. As more data arrived, another surprise emerged. Voyager's magnetometer began recording unusual changes in magnetic field orientation. Magnetic fields in space are invisible, but they influence the movement of charged particles throughout the galaxy. Scientists expected gradual variations. Instead, Voyager detected sharp transitions. Regions where magnetic directions shifted abruptly. These observations may be evidence of a phenomenon known as magnetic reconnection. Magnetic reconnection occurs when magnetic field lines collide, break apart, and reconnect in new configurations. When this happens, enormous amounts of energy can be released. Near the Sun, magnetic reconnection powers solar flares and other energetic events. Observing evidence of similar processes at the edge of the solar system suggests that this distant frontier is far more active than previously believed. It is not a quiet boundary. It is a dynamic environment shaped by powerful forces operating across vast distances. Even more intriguing were Voyager's observations of cosmic rays. Cosmic rays are high-energy particles traveling through the galaxy at nearly the speed of light. Many originate from violent astrophysical events such as supernova explosions. The heliosphere acts as a partial shield against these particles. But Voyager discovered that this protection is not constant. Some regions near the boundary appear highly effective at deflecting cosmic rays. Others allow greater numbers to pass through. This suggests that the heliosphere behaves less like a rigid bubble and more like a flexible structure responding to conditions in the surrounding galaxy. In other words, the solar system is not isolated. It is constantly interacting with its environment. Massive events occurring light years away may influence conditions near the edge of our cosmic neighborhood. Shockwaves from ancient stellar explosions. Powerful winds from distant stars. Large-scale magnetic fields spanning entire regions of the Milky Way. All of these forces may contribute to shaping the heliosphere over time. This realization has transformed how scientists think about our place in the galaxy. The solar system is not simply drifting through empty space. It is moving through a dynamic and ever-changing environment. Voyager 2 is helping us witness those interactions directly. One of the most fascinating discoveries involves plasma waves. These waves travel through charged particles much like sound waves travel through air. Voyager detected oscillations suggesting that the heliopause itself may support complex wave patterns. Researchers believe these waves could carry information about conditions far beyond the spacecraft's immediate surroundings. They may even help scientists map invisible structures extending deep into interstellar space. Each new measurement paints a richer picture of the environment beyond the heliosphere. And that picture continues to surprise researchers. Interstellar space is not empty. It is filled with motion. It contains magnetic fields stretching across enormous distances. It contains streams of charged particles flowing through the galaxy. It contains subtle structures invisible to telescopes but detectable through their effects on matter and energy. In many ways, the region beyond the solar system resembles a vast cosmic ocean. Invisible currents move through it. Magnetic storms reshape it. Waves ripple across it. And Voyager 2 is sailing through that ocean alone. Perhaps the most remarkable aspect of this story is that the spacecraft continues operating after nearly half a century. Its power supply grows weaker every year. Engineers have gradually shut down instruments to conserve energy. Components designed for a short mission have survived for decades beyond expectations. Yet Voyager keeps going. Every transmission represents another victory. Another scientific discovery. Another glimpse into a region of space that no human being has ever visited. One day, the spacecraft will fall silent. Its remaining power will eventually run out. The stream of data that has transformed our understanding of the outer solar system will come to an end. But until that day arrives, Voyager 2 continues its historic journey. It continues crossing unexplored territory. It continues sending home discoveries from the frontier between the solar system and the stars. And perhaps its greatest lesson is this: the universe is far more complex than it first appears. What once seemed like the edge of our cosmic neighborhood is now revealed as a dynamic, active frontier shaped by forces operating across the galaxy itself. The farther Voyager travels, the more mysteries it uncovers. And somewhere beyond the reach of our most distant spacecraft, countless discoveries are still waiting. Waiting in the darkness between the stars. Waiting for humanity to find them.